Hello all, I am Zach Yeldo, and in this video I will be summarizing the first portion of the article Opinion Mining and Sentiment Analysis by Bo Pang and Lillian Lee. In this summary, we will only briefly review the main points of sentiment analysis regarding classification and extraction. Sentiment analysis and opinion mining are defined in this article as the computational treatment of opinion, sentiment, and subjectivity in text. Sentiment analysis and opinion mining, which will be used interchangeably in this summary, have occurred as a response to the surge of interest in systems that deal with opinions as a first-class object. So, what other people think has always been an important piece of information for most of us during the decision-making process. But the internet and the web has now made it possible to find out about the opinions and experiences of people that are neither our personal acquaintances or well-known critics. Because most people post everything they're thinking online these days. So why is sentiment analysis important? According to 2 surveys done, over 81% of internet users have done online research on a product at least once. So if a product is being bashed online, this could be detrimental to their business if it's not identified in time. The survey also stated that consumers will pay from 20% to 99% more for a 5-star rated item than a 4-star rated item. With sentiment analysis, one can determine the current state of whatever is in question and work to address the issues that are uncovered, or even improve the user sentiment that is currently being shown. So companies are also anxious to see how their products or services are perceived. There are entire teams dedicated to identifying their company's image online, and through a sophisticated sentiment analysis system, the need for these teams could be eliminated or their efficiency could be improved. So what is the difference between a fact-based text categorization and sentiment analysis? The fact-based analysis traditionally classifies documents by topic. There could be many categories, and for a given task, there might be as few as 2 classes, which include binary classification, or it could be thousands of classes, which would be classifying documents with respect to the complex taxonomy. So in contrast, sentiment classification typically only has a few classes. For example, a positive rating or 5 stars that are generalized across domains. Also, the different classes in topic-based categorization can be completely unrelated, while sentiment labels have typically been represented as opposing or numerical categories. And the regression-like nature of sentiment analysis can also be considered unique in sentiment categorization. So the following subjects are part of what is considered when developing a sentiment analysis. One of the most difficult parts in developing a sentiment analysis is determining whether or not the text being analyzed contains subjective or objective text, or even both, and where exactly in the document it's located. We will discuss this a little bit more when we discuss sentiment polarity classification. So universal agreement on terminology online is also severely lacking, and context can make a huge difference in every analysis. So for example, posting the comments, "Go read a book," on a book review website would indicate positive sentiment, while posting the same thing on a movie review website would be seen as negative. And people are also using different acronyms and phrases online that might make no sense when you perform a sentiment analysis, like LOL or WTF, if they're not properly identified. And internet sources can vary wildly in form, tenor, or even grammatically, which demonstrates the need for robust techniques even when there is only one language involved. So when you do a sentiment analysis, it might involve English, Spanish, French, it might involve a bunch of different things. In addition, there is not much uniformity between different data sources when gathering information online. So if, for example, you're gathering movie review data, one site might have a thumbs up rating while another site might have a numerical score ranking. And this will also be discussed when we look at rating inference or ordinal regression. When a sentiment analysis is performed, disagreement and consensus points should also be represented to identify where negative or positive sentiment is coming from. Determining the overall positive or negative sentiment expressed is the final portion of the analysis, and this is done by examining particular features or aspects of items and topics contained in the data. You should also consider the strength of each opinion being analyzed, and this is also going to be discussed more throughout this video. And we can use a movie review as an example to highlight some other things that may need to be taken into consideration. So in a sentiment analysis, you might aggregate the votes that we mentioned earlier into a single uniform scale. So by doing this, you can analyze the data more simply. You can also highlight some opinions and try to identify or cluster the different communities of opinion holders. So this can help address any issues with sentiment since you are able to identify the areas of concern. So for example, a laptop might have a comment such as bad design, and if this opinion shows up a lot or the community size of this opinion is significant, then the company could take action to resolve the issue. So accounting for different levels of authority among opinion holders can also hold a significant value. So for example, if the president posts online that he doesn't like a specific political topic, it would hold much more significance than maybe, say, a 12-year-old student posting the same thing. And finally, visualization of sentiment data is typically more appropriate rather than a textual summary due to the nature of the analysis. A fundamental method in many current sentiment analyses is called classification, which is related to regression and ranking in this article in addition to classification. So classification is important because many problems can be formulated through classification, regression, and ranking. For example, making a decision for a particular phrase regarding how positive it is, or ordering a set of texts by how positive they are. And the binary classification task of labeling an opinionated document as expressing positive or negative opinion is called sentiment polarity classification, with polarity meaning positive or negative. For example, determining whether a political speech is in support of or opposition to the issue under debate. Another related task would be classifying predictive opinions in election forums into likely to win or unlikely to win. When determining sentiment polarity, you can use objective information such as laptop has long battery life to determine the overall sentiment, or you can also use subjective information such as this laptop is great. The issue with this, though, is that the distinction between subjective and objective information can be difficult to determine. For example, the battery lasts 2 hours versus the battery only lasts 2 hours. So you can kind of see where the issue lies there. There are also many challenges related to opinion mining. Early studies done on movie reviews suggest that coming up with the right set of keywords to identify sentiment is much less trivial than one might think. The reason being that sentiment can be expressed in a subtle manner, making it difficult to identify. So in the top picture shown here, you can see that it is very difficult to choose words that will accurately describe sentiment. So if you take a look at human one, it seems that those words are categorized fairly well. However, the accuracy is only 58%. Even in the statistics-based approach, the accuracy is at 69%. In other words, you can see dazzling, brilliant, phenomenal are shown as positive, and suck, terrible, awful show negative, but the accuracy is still super low. However, by applying machine learning techniques based on unigram models, you can achieve over 80% accuracy, which is much better than handpicking your word list. And a unigram is an item in the n-gram model, and the n-gram model is a type of probabilistic language model for predicting the next item in a sequence, and n-grams of size 1 are called unigrams. Discourse structure or the way text is structured overall can also affect analysis. Positive words dominate the bottom example shown, but overall sentiment is negative. So you can see that the highlighted or the words italicized are positive words, but the overall sentiment, once you read the entire passage, is negative. Additional problems surround the analysis of comparative sentences. The main idea is that sentences such as "the new model is more expensive than the old one," or "I prefer the new model to the old model," are important sources of information regarding the author's evaluations and can be very difficult to identify. Finally, going back to the ratings, the more general problem of rating inference, where one must determine the author's evaluation with respect to a multi-point scale, can be viewed as a multi-class text categorization problem. So in contrast to many topic-based multi-class classification problems, which we'll discuss later, sentiment-related multi-class classification can be naturally formulated as a regression problem because ratings are ordinal. So it can be argued to constitute an ordinal regression problem because the type of each class may not directly correspond to a specific point on the scale. Each class might have its own distinct vocabulary. So if we're classifying an author's evaluation into one of the positive, neutral, and negative classes, an overall neutral opinion could be a mixture of positive and negative language, or it could be identified with signature words such as mediocre. Term presence versus frequency. Term presence refers to whether or not a term occurred, while term frequency is how many times it occurred. And term frequencies have traditionally been important in standard information retrieval, but better performance has been achieved using presence rather than frequency. So to explain further, binary valued feature vectors and where the entries just indicated whether a term occurs or not formed a more effective basis for review of plurality classification than the analysis in which entry values increased with the occurrence frequency of the corresponding term. And term frequency and term presence are two features in a sentiment analysis that we discussed earlier. And while a topic is more likely to be emphasized by frequent occurrences of certain keywords, overall sentiment can't really be highlighted through the repeated use of the same words. So in contrast, words that appear a single time in a given text have been found to be a much better indicator of subjectivity. The position of a token within a text, for example, the middle versus the end of the document, can have an important effect on how much that token or that word affects the overall sentiment or subjectivity status of the actual text. Therefore, position information is often included in an analysis. The contrast of distance between terms, the contrast between a pair of words in an evaluation polarity was also a significant indication of sentiment. So, for example, delicious versus disgusting will help you identify sentiment better if those are both included. Part of speech and negation. So part of speech information is commonly exploited in sentiment analysis and opinion mining. This is due to the fact that part of speech tagging can be considered a crude form of word sense disambiguation, which makes sentiment more easily analyzed. So for instance, adjectives have also been shown to have a high correlation with subjectivity in sentences. And adjectives are good indicators of sentiments, and this sometimes is used to guide feature selection for sentiment classification. So in that a number of approaches focus on the presence or polarity of adjectives when trying to decide the subjectivity of a text, especially in unsupervised settings. Some sentiment analyses are also completely based off of only part of speech patterns, focusing on adjectives or adverbs. However, the fact that adjectives are good predictors of a sentence being subjective does not really imply that other parts of speech do not contribute to expressions of opinion or sentiment. So just keep that in mind. And negation can also be an important concern in opinion and sentiment related analysis. For example, I like this book and I don't like this book are considered to be very similar by most measures, with the only differing token, the negation term, forcing the two sentences into opposite classes, which would be not in this situation. So a method used in some analyses regarding negation and polarity reversal proposes attaching not to words occurring close to negation terms, such as no or don't, so that in the sentence, I don't like deadlines, the token like is converted into the new token like dash not. However, not all appearances of explicit negation terms should reverse the polarity of the enclosing sentence. So in the sentence, no wonder this is considered one of the best, it's incorrect to attach not to best because the nature of the sentence, no wonder this is considered one of the best, you're saying that it is the best, so you don't want to say it's not the best. Another difficulty with modeling negation is that negation can often be expressed in subtle ways, just like a lot of things in sentiment analysis, such as sarcasm and irony, which are both really difficult to detect in sentiment analysis. Next, we're going to talk about topic orientation and consideration. So interactions between topic and sentiment play a really important role in opinion mining. So in a hypothetical article about Walmart, let's say the sentence is Walmart reports that profits rose, and the same article about Walmart reported Target reports that profit rose. These two sentences could indicate completely different types of news, good or bad, regarding the subject of the document. And the topic of the text is really very important when determining sentiment. So if you say Walmart reports that profits rose in a Walmart document, that's good news. And if you say that Target reports profit rose in a Walmart article, that would be bad news because that's their competitor. Even when handling documents in the same domain, document topic variation is still an important consideration. The topic might sometimes be predetermined, but in most cases, the topic will be very crucial to contemplate. One approach to integrating sentiment and topic when looking for opinionated documents on a particular user-specified topic is to first perform one analysis for topic, and then once you analyze what topic they are, then you analyze the results with respect to sentiment. However, even in the case where one is working with documents known to be on topic, not all the sentences within the topic will be on topic. The solution proposed for this is a two-pass process similar to what I just mentioned, where each sentence in the document is first labeled as on topic or off topic, and sentiment analysis is conducted only for those that are found to be on topic. This is done with the assumption that if a sentence is found to be on topic and exhibits sentiment polarity, then the polarity is expressed with respect to the topic in question. A document can also contain multiple topics, and two possible suggestions were suggested in the article. The first being to consider the overall sentiment detected within the document, regardless of the fact that it may be formed from a mixture of opinions on different topics, leaving the sentiment towards the other topics undetermined. And the second solution was to identify the topics and then determine the opinions regarding each of these topics separately. So finally, there are quite a few current applications of sentiment analyses, but I'm going to summarize a few that were mentioned in the article. So one application is a review-related website. So it creates and automatically updates review and opinion aggregation. So it proactively gathers information on feedback and reviews, and it not only includes product reviews, but also opinions on candidates running for office, political issues, and more. Another application of sentiment analysis is a subcomponent technology, and it has been augmented to recommendation systems. So for example, Amazon's suggested items section doesn't suggest items with negative feedback. Also, for the detection of antagonistic language in emails and communication, it can make sure that it filters those out, and it can also be used to assist in detecting web pages that contain sensitive content in order to correctly place ads or avoid placing ads in inappropriate locations, like placing children's toys on adult websites. Sentiment analysis is also very well suited for business intelligence applications. For example, if a company isn't selling many laptops, they can look at people's opinions and personal views in addition to define specifications about the product. So subjective judgments on intangible qualities can also be analyzed, such as design is bad, such as stated previously, and can be accounted for and possibly resolved. It's difficult to survey purchasers directly compared to employing a system that just finds people's reviews and expressions of their opinions on the web, on the internet. And one can also perform a trend prediction in sales or other relevant studies by tracking public viewpoints. Finally, sentiment analysis can be used to identify opinions and sentiment in many other fields, and the application is endless. In conclusion, we have discussed the importance of sentiment analysis and why it's crucial for companies to implement in the current era. We have also reviewed a classification and extraction methods that can be used, as well as their features, and also possible issues related to classification. We went over considerations and methods that can be used during the classification phase. And finally, we observed some of the applications of sentiment analysis that have been implemented. Thank you for your time.